Stacks and queues data structure.
Hi guys! Welcome back to my channel. In this tutorial, I'm going to discuss queues and stacks data structure. First, what is stack data structure? Stack data structure is an abstract data type commonly used in most programming language. It is named stack because it behaves like a real-world stack. The basic operation of stack data structure are push, pop, is pick, is full, and is empty. First, push, storing an element on the stack. Second, pop, accessing an element from the stack. Third, pick, get the top data element from the stack without removing it. Fourth is full, to check if the stack is full. Fifth is empty, to check if the stack is empty. And now, let's see the example of stack data structure.
The implementation of stack in linked list. This is the program that shows stacks in linked list. We have class node, and under this node is initialized value elements, and self.head.next as set as none. In class linked list, it has initialized value which self.head as set as none. Under this, we have is empty, push, and pop. Is empty to return true if the stack has no element. We have push to add an element, and we have pop to remove element. If the linked list is empty, it will print stack is empty. Let's name linked list as stack to call the methods. And let's try the program. As you can see, 10, 20, 30 is pushed to stack. Then we will remove 30, 20, and 10. And the program returned to stack is empty. This is the implementation of stacks in Python. The following are the commonly used operation, which is push, pop, and get stack. But get stack is not totally the operation, but it's a way of printing the stack itself. I will just finish first this program before explaining it. This is the example of push and pop in stacks data structure. In push and pop, so the concept is last in, first out. And I will show you the output program on how this last in, first out work. As you can see on the output, I pushed plate 1 and plate 2. And I pushed again another plate, which is plate 3. Then I used pop to remove the last plate inputted, which is plate 3. In the continuation, I will show some other operation which are empty and pick. define is empty is used to determine if the stack itself is empty. Define pick is to get the top element of the stack. I will show you how this operation works. As you can see, the output is true if your stack has no element, and it will return false if it has an element. And in pick, the output is the last inputted, which is the plate 3.
Second, what is queue data structure? Queue is an abstract data type somewhat similar to stack. In contrast to stack, queue is open at the both ends. One end is used to insert data and the other end is used to remove data. The basic operations of queue data structure are enqueue, dequeue, pick is full and is empty. First, enqueue, to add an item on the queue. Second, dequeue, to remove an item on the queue. Third, pick, get the element on the front of the queue without removing it. Fourth is full, to check if the queue is full. Fifth is empty, to check if the queue is empty. Let's move on to the example of queue data structure.
The implementation of queue in Python. I will show you example program, but I will just finish it first before explaining. These are the list of elements. Rest, play basketball, play chess. Define display. It can display all the elements. Define push. You can push a new element. Also define pop. It can pop an element in a given queue. A variable choice is the part that you can choose either display, push, or pop. So let's try the program. As you can see, these are the choices, and if you enter A, all the list in queues will display. And if you enter B, you will add a new item to your queues. And when you choose A, all the queues will display, together with the last inputted item. And when you pick letter C, you will pop the first element and then enter letter A to see changes. Implementation of queue using array data structure. The function of queue is first in, first out, or FIFO. This function is to remove the first element inputted. I will show you the example program and how FIFO will run. I will just finish it first and I will explain it. extracted 11, or we can call NQ, and pop the first element, which we can call DQ. And this is the output of the program. This is the original, this is the appended, and this is the pop. That's how first in, first out execute. Here is the source code of a Python program to implement a queue using a linked list. So here's the program. For us to start the queue program using linked list, we need to make a class node that stores all the data in the program. If we're done to make a class node, we can now proceed to make a queue class. In this queue class, we define the process of NQ and DQ. In NQ process, we will add the element to the queue, while on the DQ, it will remove the element on the said queue. On the next process, we will use the while loop program. In this section, we can now ask the user to input a value for NQ and DQ. This program will now output the NQ and DQ. Picking NQ, you need to input the value itself. And when you pick DQ, you will remove its first element, which is 4. Then DQ again, you will remove the element 3. Then you will see the queue is empty because it has no longer inputted value. While when you pick with, you will end the program. What knowledge about stacks and queues is the most interesting for me? The knowledge in stacks and queues that interests me the most is their function or how the structure runs. In stacks, it is about last in first out concept, where the last inputted is the first to be out. While on the queues, it is the first in first out, where the first inputted is the last to be extracted. They have differences but can be used both in array and linked list. It is quite flexible.
That's all for today, guys. I hope you understand stack and queue data structure. Thank you for watching.